In this video, I will start talking about special relativity, and we will try to discuss the ideas in the theory through a few examples. Today we start with the first video and the first example that I will read now. Question says, we have two observers. John is in a spaceship, and the spaceship is moving with constant speed. Let's call it u, which is equal to 0.6 times the speed of light. Now this speed, remember that speed is only defined relative to somebody, to another observer. So this is the speed of the spaceship relative to the second observer, who's Ali. And Ali is located at some point A. Next sentence, John measures the length of the spaceship to be 225 meters. Now, before we go through the questions to answer, let's just look at the picture. Now remember that special relativity, it relates the observations of two observers, and those two observers are inertial observers. Now John is moving with constant speed relative to A. So A, just keep in mind that we assume that Ali at location A is an inertial frame of reference. He's an inertial observer. Since John is moving with constant speed or velocity relative to Ali, so John is also inertial observer. Both of them are inertial observers. Now, from Ali's perspective, he's looking at John, he's looking at the spaceship, and he's seeing that the spaceship is moving with a speed u in some direction, let's say up. Now let's look at the same picture from John's perspective. Now as John is looking outside the spaceship, he's seeing Ali moving with the same speed u. However, the direction of the velocity will be opposite to the first picture. So he's seeing Ali moving downward with a speed u, same, 0.6 times the speed of light. Now, which perspective should we consider? Well, either. Both of them are okay to consider. There's no difference in the physics laws between the two observers. In fact, according to the postulates of special relativity, laws of physics should be the same in both inertial frames of reference. Saying it differently, the two observers are equivalent. We cannot distinguish one observer to be better than the other observer. We can solve the problem from Ali's perspective, or we can solve it from John's perspective. So that's a major issue that I hope it's clear before we start solving the question. Now let's look at the first question, or the part A of the question. The question says, which observer, Ali or John, will measure the proper length of the spaceship? And based on that, what does the other observer measure for the length of the spaceship? So let's try to understand the situation, try to answer this question. Now, which observer, Ali or John, will measure the proper length of the spaceship? Let's go back to the picture. If you look from Ali's perspective, he's seeing the spaceship to be moving with a speed u. And that means, according to special relativity, Ellie will not measure the proper length. In fact, Ellie will measure the contracted length. He will measure a smaller length than 225 meters. If you look at from John's perspective, now John is inside the spaceship. Now for John, the spaceship, he is at rest inside the spaceship. He doesn't feel the movement of the spaceship. In fact, all what is important in discussing this problem is that John is at rest relative to the spaceship. He's seeing Ellie who's moving. So now, because the spaceship is at rest relative to John, then the length John will measure is the proper length. So the answer is John will measure the proper length. The proper length is given in the question, which is 225 meters. Now let's discuss, what does Ellie see? Now since Ellie is looking at the spaceship and the spaceship is moving relative to him, he will see a contracted length. So for Ellie, the length of the spaceship will be given by the original length, or let's say the proper length, times the square root of 1 minus the speed of the spaceship divided by c squared. Now we can substitute numbers. The original length or the proper length is 225 square root 1 minus. Now the speed of the spaceship is 0.6 times speed of light divided by speed of light, and this term should be squared, and now we can easily find the answer. And the answer will be, the answer is 180 meters. Now since the speed of the spaceship is high, it's very large, 0.6 times the speed of light, which is just an imaginary speed for a spaceship so far in our technological development so far. But assuming that the spaceship is moving at such high speed, we expect to see effects from special relativity. So according to Ali, he will measure the length of the spaceship to be 180 meters. From John's perspective, he will measure the full length, the proper length of 225 meters. I'm going to stop the video here. In the next few videos, I'm going to continue the same problem, asking for extra questions or information. See you in a coming video. If you have any questions, please leave a comment in the comment box. Thank you.